Alright, so we're going to talk about section 6.6, the system of linear inequalities. Throughout this lesson, because of the graphing, and I don't want you to wait for me to put dots and a line on it, you'll just, all of a sudden something will pop up. If you need to, pause the video so that you can add and graph that for yourself. Alright, so we're going to start with our vocabulary. A system of linear inequalities is made up of two or more linear inequalities. So we just learned about linear inequalities on Tuesday. A system is just two or more of those linear inequalities. A solution to a system of inequalities is an ordered pair that makes all the inequalities true. So we can have more than just two when it comes to inequalities. You're not limited to the number of variables equals the number of equations like we have for system of equations. So we can have, and we'll have an example where we have three or more system or inequalities in our system. The other thing I want to bring up here is the graph of our system, the system, is the region where the graphs of the, sorry, I'm reading and writing at the same time, of the individual inequalities overlap. And so we'll talk about that in our first example. But when we're graphing, and for like the practice worksheet that I have for you, when we graph, I really just need the area that would be shaded for both. You don't have to shade all the different regions. So, and then try to shade one of them darker. Alright, so our how to graph a system. Step 1, we're going to graph our first inequality. Step 2, graph second inequality, or, and then that can continue for however many inequalities you have. And then step 3, shade overlapping region. That looks amazing. So our overlapping region. So let's go ahead and get to our first example. We're going to graph this following system: y is less than 2x minus 3 and 2x plus y is greater than 2. So I'm going to start with the fact that my y-intercept is at negative 3. And then I'm going to go up to and over 1. And I'm going to continue going up to and over 1. So I continued my slope. I like to put the dots all the way across just because it makes it easier for me without a straight edge to then draw my line. I also look at the fact that this is just a less than, so that means that we are doing a dashed line. So I'm now going to create this dashed. Now, I'm going to go ahead and figure out which area I'm going to shade, but instead of shading that whole region, I'm just going to draw little arrows to say that that's the direction I will shade. And the reason I do that is so that I don't have to determine what needs to be shaded more than something else. So I'm going to plug in the point 0, 0. So I'm going to have 0 is less than 2 times 0 is 0. So 0 is less than negative 3, which is false. And so that means that this one is shading, if it will draw, we're special today. We're going to shade this direction. You don't know how many times that's popped up. There we go. All right, because it's popped up in my graphing this whole time. On this one, just so that I can have the dots all the way across, I am going to go ahead and solve this for y. So y is going to be greater than a negative 2x plus 2. So we're going to start at 2, and I'm going to go down 2 and over 1. And I'm going to keep doing that. And because this does not have the equal to, this one will also be dashed. And so I'm not going to torture you with watching me dash this line. Alright, so I've dashed it. Now I just need to determine which side I'm going to shade on. So I'm going to plug in 0, 0. So 2 times 0, 0 plus 0 is going to be 0. So 0 is greater than 2, which again is false, which means that I'm going to shade this way. And then my last step is to see where my arrows intersect. So like over here, I just have this one set of arrows, and over here I just have this one set. But here, I have both my arrows pointing to the same region, and so that is the area that I shade in. And so that's how I determine where I shade my plane. So then moving on to our next example. All right, so for this, my computer's being special. For this, we are writing the system of inequalities that are represented by this graph. So it's going to work like our last example in 6.5. I'm just going to choose the blue one because I want to. I'm going to find the slope, so I know I have a point here and I have a point there, so that means my slope is 1. So I'm going to have y blank 1x, or just x, and then I'm at negative 1, so minus 1. So I know that that is the equation. I know that because it is solid, I'm going to have the equal to line. And so then from here, I'm going to choose 0, 0 is a solution to my graph. And so I'm going to put 0, 0 in for x and y, so 0, blank 0 minus 1. And so we have 0, negative 1. And since 0 is a solution, I want this to be true. And so for this to be true, 0 is greater than negative 1. So I know that y is greater than or equal to x minus 1. And then for my next one, I'm going to do the same thing. I'm going to have y, I'm going to have a blank. I know it doesn't have the line because it's dashed. I'm going to take this point, my y-intercept here, and I'm going to take the point right, try to take the point right there. Find my slope, so down 1 over 2, so we're talking a negative 1 over 2, and that will be x. And then we are at 1, 2, 3, 4, 5, so plus 5. So we know that we have a negative 1/2 x plus 5. I just need to find my symbol. Again, 0, 0 is part of that solution, so I'm going to plug that in. So 0, and then we'd have 1/2 times 0, which is 0 plus 5. So we have 0 compared to 5, and 0 is less than 5. And so that's the symbol that will go in here. And so my system is going to be that y is greater than or equal to x minus 1, which is our blue line, and y is less than negative 1/2 x plus 5, and we found that by solving for my dashed red line, and that's how we write the system of inequalities. In our next video, we'll do our longer or more than 2 system of inequalities / word problem. So I'll see you there.